Good afternoon, everyone. I welcome you all for the problem solving session for the NPTEL course Fluid and Particle Mechanics. The course code is MOC25CH49, and we are into week 4 of the problem solving sessions. And the course instructors, as you all know, it is Professor Sumesh P. Thampi and Professor Basavaraj M. Gurappa from the Department of Chemical Engineering, IIT Madras. So, I am the TA for this course and myself Ankara. I am a research scholar from the Department of Chemical Engineering, IIT Madras. So, in today's session, we are going to see problems revolving mostly around dimensional analysis. So, we'll start that. And sorry, the session got delayed by 5 minutes because I was kind of traveling. So, but anyways, now we'll start the session, and if there are any doubts, you can stop me anytime and ask. I want the session to be interactive as much as possible. So yeah, we'll start now, and we can compensate the time at the end if required. So, as you all know, this fluid and particle mechanics is a 12 weeks course. So mostly in the first few weeks, we will be seeing about introduction to Navier-Stokes equation, the solution, Poiseuille flow, Taylor-Couette flow, rheology, dimensional analysis, turbulent flow, frictional losses, Moody's chart, boundary layer theory, and followed by particle mechanics by having introduction to particles, characterization, particulate phenomena, motion of particles in a fluid, sedimentation of dilute, concentrated and flocculated dispersions, packed and fluidized beds, and filtration. So these things you all know. I don't want to repeat it at every class because it is like time consuming thing. But anyways, we are now doing dimensional analysis and turbulent flows. We are dealing with those two things in week 4. So as per books and references, we have 3 books and few references which I would suggest you people to read if you are in undergrad. Mainly focus on reading Unit Operations of Chemical Engineering by McCabe and Smith, and Fluid Mechanics by Frank M. White is very good book for having a wide knowledge on fluid mechanics. And for particle technology, you can go with Martin Rhodes. But mainly, if you are focusing on Unit Operations of Chemical Engineering by McCabe and Smith, it will give you a very good understanding of all the concepts, and which will help you if you are undergrad and if you are preparing for your interviews, those things. It is a very good book as per my thing. So now, yeah, lastly you have transport phenomena, bird, steward and foot, light foot. So now, week 4, we will be seeing what we have seen in the course. So in week 4, what course was covered is choice of scaling parameter, non-dimensional analysis 2, and non-dimensional analysis 3, Buckingham pi theorem. So these are the 4 videos which you would have seen in the course. So before moving on or starting the problems, I would like to have a few things listed out. So first thing is that the course content is well given by the professor during their course work. I mean, in the lecture videos, the course content is well explained by the professors. So then why are we having these sessions? We are having these sessions to help you solve the assignment problems, which will have a certain percentage or certain weightage in your final marks. So that is the reason behind we having the sessions. So now, without any further delay, we can start the session. So in today's class, we are having very less number of problems, that is 10 problems on the whole. But we are going to go very slowly, and we are going to make you well understand the concepts. So that is the only motto we have today. So question 1 is that, okay, we'll first read the question. Okay, here just a slight variation is there in the question. Yeah, we have so these are all the things which we know already, and this is something which we will be focusing on. I mean, in similar problem we will be seeing. There is one more term. I mean, one more area I need to change in the PPT, which I will do it as it comes. So the first question is, laminar flow through a pipe is unstable at high Reynolds number. Investigations indicate that the Reynolds number for transition to turbulence is approximately 2300 in a circular tube. If the Reynolds number is calculated based on the diameter of the pipe and the average velocity of the fluid flow. If D is equal to 20 centimeter and the fluid is kerosene at 20 degrees Celsius, which has a dynamic viscosity of 1 into 10 power minus 6 meter square per second, find the volumetric flow rate in meter cube per hour that causes the transition. So what are we given? We are given that laminar flow through a pipe is unstable at high Reynolds numbers. So which is true. And while researchers were doing investigations, it indicated that the Reynolds number for transition to turbulence is approximately 2300 in a circular tube. So we know that Reynolds number uh, confirms which regime of fluid flow is happening inside the system. If it is a low Reynolds number, we call it laminar flow. If it is a high Reynolds number, we call it turbulent flow. If it is between if it is between that range, we will call it transition regime. So obviously, when the Reynolds number is high, it means it is a transition regime. So laminar flow through a pipe is unstable. So there will be a lot of uncertainties which is happening inside the system at the turbulent flow. Or instead of saying turbulent flow, we can call it high Reynolds number flow. Investigations indicate that the Reynolds number for transition to turbulence is approximately 2300 in a circular tube if the Reynolds number is calculated based on the diameter of the pipe and the average velocity of the fluid flow. So they have stated that transition to turbulence, that is from laminar to turbulence, during the transition, if the Reynolds number is approximately 2300 for that in that transition regime. So this is calculated based on the diameter of the pipe. So as we all know, the Reynolds number calculation is on several bases depending on the type of Reynolds number which we are calculating. So if it is a particle Reynolds number, I mean, it is basically rho into V into characteristic length divided by mu. Rho V L by mu, rho V D by mu, whichever. For pipe flow, that is with a circular cross section, we will be using rho V D by mu, where D is the diameter of the pipe. But instead, as I mentioned, if we are calculating for the particle Reynolds number, what we will be doing? We will be calculating it as rho into V into dP by mu. Here dP means that the diameter of the particle. Here it does not relate it to the diameter of the column or something, but rather it denotes the diameter of the diameter of the particle. So in that context, what is given here is that we are considering the pipe flow. So Reynolds number is equal to rho V D by mu. Here D is the diameter of the pipe and V is the average velocity of the fluid flow and rho is the density, and divided by mu, and mu is the kinematic viscosity. What is given in the question? In question it is given diameter of the pipe is 20 centimeter and fluid is kerosene at 20 degrees Celsius and its dynamic viscosity is 1 into 10 power minus 6 meter square per second. So here again I am mentioning that don't check fluid and its properties. I'll better change because kerosene. Fluid is at 20 degrees Celsius, which has a dynamic viscosity of 1 into 10 power minus 6 meter square per second. So now we are asked to find the volumetric flow rate in meter cube per hour that causes this transition. So what we need to do, we need to calculate the volumetric flow rate. So for what is volumetric flow rate? It is that the volume in that volume which is flowing in that particular time duration. So here we are asked to find it in that meter cube per hour unit. So how do we get the volumetric flow rate? If we know the velocity with which the fluid is traveling, and if we know the cross sectional area through which the fluid is traveling, that is, if we know the pipe cross sectional area through which the fluid is moving with certain velocity. So I am hoping you are able to imagine. So it is just that it is this. In this, the water is flowing with certain velocity, and this is the cross sectional area. So if we multiply velocity by cross sectional area, we can get the volumetric flow rate. So for that, now that is how we are going to calculate the volumetric flow rate. So what do we require? We need to know the area of the pipe, that is area of the cross sectional section of the pipe, and V is the velocity with which the fluid is moving. So these two things we need to calculate. So here in the question it is given that Reynolds number is 2300 and pipe diameter is also given. So if we know Reynolds number and if we know the pipe diameter and we are given the dynamic viscosity. So what is dynamic viscosity? It is given in 1 into 10 power minus 6 meter square per second. So dynamic viscosity is nothing but okay, it is not it is actually it is kinematic viscosity. It is actually kinematic viscosity, not dynamic viscosity. Just remove this. Has a viscosity of 1 into 10 power minus 6 meter square per second. So since it is given in meter square per second, we need to know what it is. It is not. It is dynamic viscosity. It is kinematic viscosity. So anyways. So here it is viscosity of 1 into 10 power minus 6 meter square per second unit. So dynamic viscosity unit is actually kg per meter second. And divided by rho, that is density, that gives us this velocity kg by meter cube. So it is mu, that is dynamic viscosity, by rho. Even though the wording is wrong, but on seeing the unit we can say that it is mu by rho, that is mu. So mu by rho is 1 into 10 power minus 6 meter square per second. So we know that Reynolds number is equal to, all these things are given in next slide as well, just for rho Vd by mu. So this mu by rho becomes this viscosity, kinematic viscosity, that is nu. So that is how we are getting the answer. I mean, we are getting the viscosity value. So now if we give that Ra is equal to Vd by nu. So in this we know V, in this we don't know V, we know Reynolds number, we know nu, that is viscosity, and we know diameter of the pipe. So what else we can find it from here? We can find the velocity from here. So that is how we are going to do it. So question 1, we will see first what is given. Reynolds number is given as 2300. That is the Reynolds number at which during which the transition takes place from laminar to turbulent. Second one, diameter of the pipe is given as 20 centimeter and we are converting it into meter. And third, it is given fluid is at 20 degrees Celsius. I'm just removing the mention of kerosene because kerosene's viscosity is not this value. And viscosity is nu, which is 1 into 10 power minus 6 meter square per second. So now to find, we are asked to find the volumetric flow rate in meter cube per hour that causes the transition. So what are we going to do? We are going to calculate it by using the Reynolds number formula. So first, volumetric flow rate we will obtain by V into A. So for that we need to calculate V, and for that we are going through the Reynolds number approach. So Reynolds number is equal to rho V d by mu, and it is V d by nu. That is mu by rho is equal to 1 into 10 power minus 6 meter square per second. So now, okay. So nu, if we take it to the other side, we will be getting nu is equal to V into d by Re. So that is what we are written here. Nu, okay, not nu. V we need to find. So V is equal to Re into nu by d. So Re into nu by d gives us V. So here V we are going to calculate. So we are taken Reynolds number as 2300. The point at which the transition takes place, and nu is 1 into 10 power minus 6 divided by d. D is 20 centimeter or 0.2 meter. So on substituting, we are getting the value as V is equal to 0.0115 meter per second. So this is the velocity at which the fluid is flowing through that particular pipe. So now we know the fluid velocity, we can calculate the diameter, area of the cross section of the pipe. So Q is equal to V into A. A is equal to pi by 4 d square because the cross section is circular cross section. So we are using this approach. So Q is equal to V is 0.0115 into 3.14 divided by 4 into d square. D square is 0.2 square. So now what we are getting? We are getting 3.6 into 10 power minus 4 meter cube per second. So this is volumetric flow rate in meter cube per second. That is for 1 second. 3.6 into 10 power minus 4 meter cube is flowing through that particular pipe. So 1 meter cube is approximately 1000 liters. So if we calculate in liters, it is 0.36 liters. So it is like 360 ml around. 360 ml, right? Yeah. So 360 ml is flowing in that particular cross section, that is 20 centimeter pipe. So that is how we can relate. If it is 3.6 into 10 power minus 4 meter cube per second, we need to calculate what it will be for an hour. So what to do? We have just we have to multiply it by 3600 to get it for 1 hour, meter cube per hour. So that is what we are doing, 3.6 into 10 power minus 4 into 3600. So that gives us 1.3 meter cube per hour. I hope it is clear. So answer is 1.3 meter cube per hour. That is the answer. So what we did, we are asked to find the volumetric flow rate. For that, we are given Reynolds number in the transition zone is 2300. So by using Reynolds number and Reynolds number formula, what we got velocity value, that is average flow velocity. And after having obtained the average flow velocity, we have multiplied that by the cross-sectional area. Since it is a cylindrical pipe, we have circular cross-sectional area, and we got the volumetric flow rate, and finally it was asked in meter cube per hour. So we have multiplied it by 3600. So it is 1 second is 1 by 3600. Yeah, I mean 1 by 3600 hour. 1 hour has 3600 seconds. So 1 second is 1 by 3600 of an hour. So it is like 1 by 3600. So 3600 goes to the numerator. So we getting the final value. So I hope it is clear. If you have any doubts, you can ask me by stopping at any point. So yeah. So next question is, determine the dimension of the following combination of variables. Each symbol has the usual meaning. So we are asked to find the dimension of the following combination of variables, and each symbol has usual meanings. Meaning mu means it is viscosity, and rho means density, u means velocity, t means time. So in that basis they are given. So first one is rho into dou u by dou t, and second one is dou p by dou z. So first we are asked to find the dimension of the following combination of the variables. So what we are going to do, we are going to first write the first question. So in first, once again I'll just come. Okay, so first one is rho into dou u by dou t. So what is the what was asked, dimension of the following combination of variables. So rho here is kg per meter cube, and u here is meter per second, and dou gets cancelled actually, and t is seconds. So those units, if we substitute here, we will get the answer. So that is what we are going to do now. So we'll do that. So dimension of rho is kg per meter cube. So it is kg is m, that is mass, meter is length, so it is m l minus 3. And dimension of u is meter per second, and therefore it is m is length and s is time, so l t minus 1. And dimension of t, it is seconds, so it is t, just t. So now we have to substitute everything back in this particular format, and therefore it becomes dimension of rho dou u by dou t is equal to rho is ml minus 3, and dou u is L into t minus 1 divided by t. If you are finding anything wrong, please stop me. So m L minus 3 L t minus 1 by t. So what happens? L minus 3 plus 1, so it is minus 2, m remains the same, and t is minus 1, so it becomes minus 2. So dimensions of rho is, I mean this particular thing is ml minus 2 t minus 2, or it is kg meter minus 2 second minus 2. So next one is dou p by dou z. So here again dou won't be making any difference. So dimension of P is force per unit area in general. So it is Newton by meter square. That is Pascal is Newton by meter square. So Newton is F is equal to m into A. So kg into meter per second square divided by meter square. So it becomes kg by meter into second square. So this particular m and one of the m gets cancelled. So it becomes kg by meter second square. So how will we write? We will write it as kg is m, L minus 1, T it is minus 2. Why did I write as it is minus 2? And dimension of Z is m or it is L. Z is m, that is L. So dou P by dou Z becomes m L minus 1 T minus 2 divided by L. So m L minus 2 T minus 2. So here we are able to see both A and B has the same unit. So that is how we are finding the dimension of these two particular terms, and that is how we do question 2. Now we are going to question 3. Okay. In question 3, let us see what is asked. Convection heat transfer data are often reported as a heat transfer coefficient H defined by Q is equal to HA into delta T, where Q is equal to heat flow in joules per second, A is surface area which is given in meter square, and delta T is the temperature difference in Kelvin. So I am hoping first statement is very clear for all of us. So convection heat transfer data are often reported as a heat transfer coefficient H. So H we use the convective heat transfer coefficient, and here we are using H in the Q equation, that is Q is equal to H into A into delta T. So if Q is equal to H into A into delta T, here Q means heat flow in joules per second and A is the surface area. So since it is area, its unit is meter square, and delta T it is the temperature difference. So here it is Kelvin. So this is the statement. A commonly used dimensionless form of H is the Nusselt number, which relates the convective heat transfer coefficient to the conductive heat transfer across the fluid layer. Suppose the Nusselt number can be expressed as a product of physical quantities. Nu is equal to H power A, K power B, L power C, where L is the characteristic length, K is the thermal conductivity of the fluid. So L's unit is meter and K's unit is watt per meter Kelvin. Use dimensional analysis to find the exponents A, B and C that make the equation dimensionless. So here what are we given? We are given that convective heat transfer data is reported as Q is equal to H into A into delta T. So Q is the heat flow and it is in watts, or watts is equal to joules per second. And A is surface area. So here A denotes meter square again. Its unit is meter square, and delta T is temperature difference, and its temperature difference is given in Kelvin. So now what we are doing is a commonly used dimensionless form of H. H we define it in various dimensionless number, one of which is Nusselt number, and it relates the convective heat transfer coefficient to the conductive heat transfer coefficient, and it is given as the physical quantities, product of certain physical quantities. Nusselt's number is equal to H power A, K power B by K power B, L power C. So here what it means is that K is the thermal conductivity of the fluid, and it is in watt per meter Kelvin, and L is the characteristic length. So it can be anything. So now we are asked to find what this expression is. So that we have given the expression as H power A, K power B, L power C. So we are asked to find what is A, B and C, so that the equation has become dimensionless. So that is the question. So we need to find the values of A, B and C, so that the Nusselt number is equal to this particular form becomes dimensionless. So I hope it is clear. Now we will start the thing. It is a very simple problem. So now what we are required to do is we first need to write the dimensions of all the quantities given in the question. So given is q is equal to h into a into delta t, and h we can write it as q by a into delta t. So units of h is in the question, h unit is not given. So but Nusselt number is equal to h into a k into b l power c, not into, it is h power a k power b l power c. But we are given the units of k and we are given the units of l in the equation, but we are not given the units of h in the question. So, but rather we are given the units of all these terms. Q dot is equal to HA into delta T. So, from this particular expression, we are finding the units for H. H is equal to Q dot divided by A into delta T. So, what is the units of Q? Q dot is joules per second, that is heat flow per unit time. So it is joules per second divided by A is given in meter square and delta T is given in Kelvin. So it is joules per second meter square Kelvin. Joules is Newton into meter. So Newton meter per second divided by meter square Kelvin. So how can we rewrite it? It is meter and meter square gets cancelled. So it becomes Newton divided by seconds into meter into Kelvin. So this is the final expression. So now here Newton is force unit. So force is F is equal to m into A. So m unit is kg, A is acceleration. So acceleration is velocity by time. So velocity is meter per second. So acceleration is meter per second square. So I'm just saying all this so that it will be you can write it by heart whenever you are solving any problems. That's why I'm like saying all the small things also. But if yeah. So it is kg meter per second square divided by second, meter and Kelvin. So now what happens? Meter and meter gets cancelled. S square and S becomes S cube and 1 Kelvin remains. So it is kg per S cube into Kelvin. So in general the unit of H is watt per meter square Kelvin, but rather here we are just simplifying it into the basic units, basic dimensions, that is m, l, t and theta. We don't want to use complicated the things, because finally whenever we are solving any problems we will be reducing it into the basic units of mass, length, time and if temperature is the temperature. So that is the reason why we have written it as this. But rather units of H, we all know it is watt per meter square Kelvin. Watt is joules per second, and so we are dividing. If we are not remembering units of H, we can derive it from Q as well, which is given in the question. So that's why we have gone that long route. But anyways, H is kg per second cube Kelvin. So that is a simplified unit expression for H. So here we are not, we can see that there is no meter square. What happened to that meter square actually? Newton, okay, kg. Yeah, that meter square got cancelled, so it is not. So now what else we require? H, Nusselt number is equal to H into K into L, each raised to a powers of A, B and C respectively. So now since H is calculated, what are we going to do? We are going to calculate the next other things are given in the question. Units of K and L are given in the question. So we are just writing the table, like what is the unit of H, K and L. So first one is the convective heat transfer coefficient H, and we have found out the unit as kg divided by second cube into Kelvin. So here kg is m, L is not there, T is -3 and temperature we are denoting it using theta. Theta is -1. Second one we have thermal conductivity K. So thermal conductivity unit is watt per meter Kelvin, or it is again what it will come, it is watt per meter square Kelvin is this. So watt per meter Kelvin will be one, this into meter will give that unit. So it is kg meter per second cube Kelvin. Or else also, if we simplify also, we will be getting the same thing. And its dimension is kg is m, meter is L, S cube is T minus 3 and Kelvin is theta minus 1. And characteristic length is L in meter and its dimension is L. So meter and it is L. That is a relation. So I hope it is clear till now. So till now we haven't done anything. We just wrote expressions for, the dimensions for all the quantities involved in the question. So what was given in the question? In the question it was given that Nusselt number is equal to h power a, k power b, l power c. And what is the exponents a, b, c such that Nusselt number becomes dimensionless? That was the question. So nu dimension is 0. It does not have any dimension. So now keeping that in mind, okay, we wrote dimensions of each quantities. It is h power a, not ha. So nu is equal to h power a, k power b, l power c. So now we are substituting all the dimensions which we have obtained till now into this particular equation. So nu is equal to m into t power minus 3 into theta power minus 1 to the whole to the power of a, and k is m into 1 extra addition of l, t power minus 3 theta power minus 1 to the power whole to the power of b, and L to the power of C. So we have just substituted all those things which we have found out from here back in the equation. And now we are comparing the dimension of LHS and RHS. So if we see that, if we write this particular thing in the LHS side, it will be 0, 0, 0. So basically we have everything 0 in the left hand side. So now on the RHS side, equating RHS, we get this, okay. So nu is equal to m to the power of 0, everything becomes 0. So now equating RHS, we have, for m we have m to the power of a. So we are just taking the powers a plus b, and not equating, considering exponents in RHS. You can see that for m we got these particular values. M is a plus b, and L is we have only b and c, so it is b plus c. And for t, what will we have? We will have minus 3a plus minus of 3b, and that's it, minus 3a minus 3b. And for theta, we will be having minus a minus b, minus a minus b. So if we look at it, we have three A, B, C. Three unknowns and we have four equations, but in these four equations, this equation for m, this equation for t, and this equation for theta all are same. It basically reduces to a plus b. So we will just look at it in the next slide. First one, we are just now equating the LHS and RHS. So a plus b is equal to 0, first equation. B plus c is equal to 0, second equation. Minus 3a minus 3b equal to 0, third equation. Minus a minus b equal to 0, fourth equation. 1, 3 and 4. All three equations reduces to the single form, that is a plus b is equal to 0. So now we have a plus b is equal to 0, b plus c is equal to 0. We have two equations but three unknowns. So the problem is under specified. I'll just check once. Okay, yeah, it is under specified problems where there are fewer equations than the unknowns. There are, we will have infinitely many number of solutions. So basically that is the meaning. So now, so we can have a number of solutions because there are a few number of equations but more number of unknowns. That is 2 equations and 3 unknowns. So how can we solve? We will just take equation 1 and 2. A plus b is equal to 0. So b is equal to minus a. And from 2, b is equal to minus c. So a equal to c. That is what we can find out, right? A is equal to c equal to minus b. So whatever value we take for a, it will be the same for c and it will be the same for same in magnitude, but sign will be different for b. So that is the thing. So here we can take 1, 2, 3, whatever it is, but now we are taking it as 1 and a equal to c. So now we are choosing c is equal to 1. So it gives us a is equal to 1, b is equal to minus 1 because b is equal to minus of a or b is equal to minus of c. So that is the thing. So since the equation itself, the question itself led to the possibility of having infinitely many possible solutions. So we chose this particular value for c and from there we got the solution. So now we are substituting these things back in the equation for Nusselt number. So Nusselt number is equal to h power a, k power b, l power c. So this was what was given in the equation, in the question. So now after finding out the values for a, b and c, what we are doing, we are substituting back in this particular equation. So it becomes nu is equal to h power 1, k power minus 1, l power 1. So it is hl by k. So that is the equation. So this is the Nusselt number. So mostly we will be using it as nu is equal to hd by k, where d is the diameter of the pipe. So here L is just characteristic length. L denotes the characteristic length. So basically coming back to the equation, now this equation is dimensionless. That is what we were asked to find the values of a, b and c such that we will get a final expression for nu that will be dimensionless. So here it is dimensionless. So I'll just prove you that. Where is my pointer? Yeah. So here H is, as I mentioned, it is watt by meter square Kelvin, right? So L is in meter divided by watt by meter Kelvin. So here it meter square and meter gets cancelled, and we will have the same unit and it becomes cancelled. So now instead of 1, if we have chosen 2, A would have become 2, B would have become -2 and so on. But even then what happens is H should have been square, L would have also been square. So it is like this is square and this is square. So m square and m power 4, again we will cancel 1 m square. When this becomes square, we will have the same expression. So that is the basic thing. So whichever value of C we choose, we will get the dimensionless expression. So that is the meaning. But mostly Nu is equal to Hd by K is what we will be using in most of the applications or most of the problems. So that is how we calculate answer for question 3. So I hope it is clear. Now I hope it is clear. If are we having any doubts at any point? Okay. So we will continue. Okay, that is how we do question 3. Now we are into question 4. So in question 4, again I guess it is a similar question, I remember. In fluid flow and heat transfer, fluid properties like viscosity and thermal conductivity strongly influence the nature of convective heat transfer. A dimensionless number that characterizes this influence is the Prandtl number, which compares momentum diffusivity to thermal diffusivity. Suppose the Prandtl number can be expressed as a combination of physical properties in the form Prandtl number is equal to mu power A, Cp power B, K power C, rho power D, where K is the thermal diffusivity, mu is the dynamic viscosity, and Cp is the specific heat at constant pressure, K is the thermal conductivity, and we are given the values. Why did something is wrong? No. Cp, mu, Cp, K. It's not thermal diffusivity. Okay, that was a wrong statement. So using dimensional analysis, derive the values of the exponents a, b, c and d that result in a dimensionless quantity for the Prandtl number. So what are we given? We are asked that in a fluid flow and heat transfer, properties like viscosity and thermal conductivity strongly influence the nature of convective heat transfer. A key dimensionless number that characterizes this influence is the Prandtl number, which compares the momentum diffusivity. Momentum diffusivity is through viscosity. So it is kinematic viscosity. Kinematic viscosity is given by nu to thermal conductivity K. Suppose Prandtl number can be expressed as a combination of physical properties in the form Prandtl is equal to mu power A, Cp power B, K power C, rho power D. So mu is the dynamic viscosity, Cp is the specific heat at constant pressure, and K is the thermal conductivity, and rho is the fluid density. So now using the dimensional analysis, we have to derive the values of A, B, C and D so that the whole quantity becomes dimensionless. So similar to how we did in the last problem, we have to do this as well. So yeah, we'll start. So yeah. So similar to last problem, we are going to solve this problem as well. So first we are writing the dimensions of the all the quantities given in the equation. So first one is dynamic viscosity mu, its unit is kg per meter second. So we can write it as m L minus 1 T minus 1. Next one is specific heat capacity Cp, and its unit is joules per kg Kelvin. So it is the heat required to raise the temperature of 1 kg of material by 1 Kelvin. So it is joules per kg Kelvin. So joules is Newton meter and Newton is kg meter per second square. So it becomes kg meter square by second square by kg Kelvin. So it becomes meter square by second square Kelvin. So that is how we got. If you solve this, you will get the same answer. So now after thermal conductivity, after we have obtained the thermal conductivity, we are just substituting the values. So it becomes kg is m, meter is L, time seconds is T minus 3, and Kelvin we are writing it as theta minus 1, and density we are giving it as rho, and it is kg by meter cube. So it is kg is m, again m here is mass not meters, and L here is the characteristic length denoting the meter units. So m L minus 3. So this is how we are just specifying the dimensions for all the quantities given in the question. So writing dimensions of each quantities which we have written. Next step is to get it to this form. So PR is Prandtl number and it is given by mu. PR is equal to mu to the power of A, Cp to the power of B, K to the power of C, rho to the power of D. So now after that we are substituting all the values, all the dimensions in this particular form, and what will we get? PR is equal to mu and it is m L minus 1 T minus 1 whole to the power of A into Cp. It is L square T minus 2 theta minus 1 to the power of B, and K is m L T minus 3 theta minus 1 to the power of C, and rho it is m L minus 3 to the power of D. So we have just expanded the dimensions and put it in the original question. So now what we have to do, we are just again like previous question, we are just equating. So for m, what all powers we got? We got 1a and we got 1c and we got 1d. So it is a plus c plus d. And L it is minus a plus 2b plus c minus 3d. So we have taken it for all L and we got minus a plus 2b plus c minus 3d. And for T we have got it is minus a minus 2b and minus 3c. And for finally theta, that is for Kelvin, what have we got? We got minus b minus c. So these are all the terms corresponding to the particular dimensions. And since Prandtl number, that is PR, has dimension of 0, it is basically a dimensionless number. So dimensions for all it is 0. So we are putting 0 in all, and we will get it as a plus c plus d is equal to 0, minus a plus 2b plus c minus 3d is equal to 0, and equation 3 is minus a minus 2b minus 3c equal to 0, and last is minus b minus c is equal to 0. So again what we have here is we have 4 equations and we have 4 unknowns a, b, c and d. So number of equations equal to number of unknowns. So it is a proper problem, that is well posed problem, something like that. Yeah, well posed problem. So number of unknowns is equal to number of equations. So it is the same. So we have 4 unknowns and we have 4 equations. Now what will we do? We will solve for the values of A, B, C and D. So solving, first what we will do, we can take last equation, that is 4, and we will get B equal to minus C. So we keep 1B and we take it to the other side. So B is equal to minus C. And substituting it in 3, we will be having minus A, B is equal to minus C. So what it becomes? Minus 2B becomes plus 2C. Minus 3C is equal to 0. So basically it shows that minus A minus C is equal to 0, or A is equal to minus C. So now we know A, we know B, and we can substitute in 1. So A is equal to minus C. If we substitute in 1, what happens? A plus C plus D equal to 0. A is equal to minus C. Minus C plus D is equal to 0. So these two terms cancel out each other and D becomes 0. So substituting in 2, we will be having minus A plus 2B plus C minus 3D equal to 0. So D becomes 0 and A is minus C. So minus of minus A is plus C. So C plus 2B, B is equal to again minus C. So it becomes minus 2C plus C is equal to 0. Okay. See, I mean it cancels out. So what we can do is, after getting D as 0, if we substitute back in the equations, we will be having A plus C equal to 0, minus A plus 2B plus C is equal to 0, minus A minus 2B minus 3 is equal to 0, minus B minus C is equal to 0. So again it becomes, what happens? It becomes, what do we call? Under specified problem after we have found out the value of D. So whichever value we give, it will be like cancelling out each other. So rather, since it becomes under a specified problem, we are now going to choose a particular value for one variable, and from there on we will get the value for the rest of the things. So similar to last problem, we are now going to choose some value for C, because now the number of unknowns has become 3 and still the number of equation is 4. So we are just choosing one problem. Okay, not under specific, I mean it is not under specified problem, but now whichever value you substitute, it will become like a 0 thing. I mean wherever you substitute, it will be like same thing. So our conclusion, it is not under specified problem now, but our conclusion is B is equal to minus C, A is equal to minus C, D is equal to 0. So A is equal to B. Basically A is equal to B, and both of them are equal to minus C. So whatever value we choose for C, we can get it negated for A and B. So if C is equal to 1, A is equal to minus 1 and B is equal to minus 1. And if C is equal to 2, A is equal to minus 2, B is equal to minus 2. So that way we are seeing, it is not under specified problem as I mentioned earlier, but we have A is equal to B is equal to minus C. So that is the conclusion which we have drawn from analyzing the problem and solving the equations. So after getting that, what we are going to do, we are going to substitute it back in the equation. Prandtl number is equal to mu to the power of A, Cp to the power of B, K to the power of C and rho to the power of D. And we are substituting everything back. Mu to the power of minus 1, Cp to the power of minus 1, K to the power of 1, rho to the power of 0. So it becomes K is K divided by mu into Cp, or we can also write it as K mu Cp by K. So Prandtl number is, that is how we write in the final form, right? Like Prandtl is equal to Cp mu by K. It is like that dynamic viscosity by thermal conductivity, molecular diffusivity by thermal diffusivity. So final form is this. This we will obtain directly if we choose C as minus 1. C is minus 1, A and B are 1. So if we substitute, it will be like Cp mu by K. Directly we will be getting. So again, are we getting the final form that is dimensionless? So we can check it actually. Kg, I am taking for this particular format. So it is kg by meter second and it is joules per kg Kelvin. And this one is watt by meter Kelvin. So we can cancel Kelvin, Kelvin, kg, kg gets cancelled. And again meter and meter gets cancelled. Joules per second is watt. So this watt and this watt also get cancelled. So this is the dimensionless form and we have correctly obtained the dimensionless form as well. So that is how we do it. Now let us move on to question 5. So I think we'll take okay, no need. Question 5. Okay, now we are going to do the pi theorem. So I think it's better if we continue it. If you any one of you want some 5 minutes break, let me know. We can take. Okay, now moving on to the question, we have the pressure drop per unit length delta P by L in a porous rotating duct depends upon average velocity, density, viscosity, height, duct height, wall injection velocity and rotation rate sigma. What is this? Yeah, I forgot its name, but let us keep it sigma. The pressure drop per unit length delta P by L in a porous rotating duct. So we have a porous and it is a rotating duct and the pressure drop inside it is pressure drop per unit length delta P by L. It depends on average velocity V, density rho, viscosity mu, duct height H, wall injection velocity VW and rotation rate sigma. Rotation rate. So now using the dimensional analysis, give the expression for this problem where f denotes the general function. So again for this problem we are just listing out the quantities given in the question. So here delta P by L is equal to F into V, that is average velocity, rho density, mu dynamic viscosity, H wall duct wall height and sigma and VW it is wall injection velocity. So now we are going to write the dimensions for all of it. So pressure drop per unit length and it's represented as delta P by L and its unit is pressure drop is Newton by meter square and L is meter. So it is Newton by meter cube. So if we write, we will be getting it as kg meter per second square divided by meter cube. So it becomes kg by meter square second square. So it is kg is m by meter square. So L minus 2 by second square. So it is t minus 2. Second one, it is average velocity. So V it is in meters per second. So it is L t power minus 1. Third one, it is fluid viscosity. So it is given by mu and its units is kg by meter second. So it is kg is m divided by L for meter and t for seconds. So it is m L minus 1 t minus 1 and density kg by meter cube. So it is m L minus 3. Duct height is in meter, so it is L. Wall injection velocity, again it is in meter per second, so it is L t minus 1, and rotation rate is per second, number of rotations per second, so it is 1 by S or it is t minus 1. So that is how these are all the units. So now we have written the dimensions of each quantities. So after that, what we are going to do is we need to first identify how many pi groups are there. So in the question we have number of variables, we have 1, 2, 3, 4, 5, 6 and this one including 7. So for identifying number of pi groups, so using the Buckingham pi theorem, we have number of variables as 7 and fundamental dimensions in the problem we have M, L and T. We don't have anything else, so it is number of fundamental dimensions. So it is 3. MLT is equal to 3. So okay, I think it is a bit confusing, right? Should have given us just like this. Otherwise, it is like continuation something. MLT, so it is K is equal to 3. Expected dimensionless groups, therefore it is n minus k, so it is 7 minus 3, it is 4. So we are expecting 4 dimensionless groups. So now what we need to do, we are first identifying the repeating variables in all these 3. So velocity is repeating, so we can take LT minus 1, and for having mass we can go with density, that is kg per meter cube, and one more thing what we can give, H. So we have M, L and T, so we are going with H, that is L. So now the non-repeating variables are, one is delta P by L and the second one is injection velocity VW, and we have rotation rate sigma and viscosity mu. So that is the thing. Now what we are going to do is, we are going to build a dimensionless group. So we will be having 4 pi groups, pi. So it is pi 1. First we will write it based on delta P by L. So pi 1 is equal to delta P by L, and we have repeating variables V, rho and H. So V power A, rho power B, H power C. So after that, pi 1, it is delta P by L. What is the unit of delta P by L? Its unit is M, L minus 2, T minus 2. And V unit is meter per second. So it is L, T minus 1 to the power of A. And rho, it is kg per meter cube. So it is M, L power minus 3 to the power of B. And H unit is L. So L to the power of C. So that is the dimensionless pi group 1. So now what we are going to do, we need to identify the dimensions. So M is 1 plus B, and second L, it is minus 2 plus A minus 3B plus C. Minus 2 plus A minus 3B plus C. And T, it is minus 2 minus A, and here in these two terms we don't have T. So it is minus 2 minus A. So again, what if we are equating it to 0, what we will be getting? A is equal to minus 2. Minus 2 minus A equal to 0. So A is equal to minus 2. So A we got as minus 2. Similarly, B we can get it as minus 1. B is equal to minus 1. Now we are substituting both of this in this particular equation. So it becomes minus 2 minus 2 minus of minus 3B, minus of minus 3. Sorry, minus 3 into minus 1. So it becomes plus 3. So plus 3 minus 4, it is minus 1. So C is equal to 1. So pi 1, it becomes M, L minus 2, T minus 2, L T minus 1 to the power of minus 2, M, L minus 3 to the power of minus 1, L to the power of 1. So we are substituting back in the original equation. So delta P by L, V minus 2 rho minus 1 H is 1. So delta P by L into H by rho V square equal to delta P by L divided by rho V square by H. So we can write it in this particular form also. Whatever the form, it doesn't matter. It is just that approach we should be seeing. So out of the 4 pi groups, we have seen one first group. Second one, we are pi 2 and we are going to change the basis. So previously we have taken delta P by L. Now instead of delta P by L, we have 3 more non-repeating groups. So we are taking that mu. So it is mu into V to the power of A, rho to the power of B, H to the power of C. So substituting it, what we are getting, unit of mu is kg by meter second. So it is m, L minus 1, T minus 1. So similarly for rest of all the things, we are writing the original dimensions, and we are having the powers. So now what we have to do, we have to we have to now separate the units for each. So m is 1 plus b. So how we got here, it is 1 and here it is b, m 1 plus b. For L, what will we get? We will get minus 1 plus a minus 3b plus c. Minus 1 plus a minus 3b plus c. So that is the unit for L. And for T, we will have minus 1 and it is minus a. So again we are equating everything to 0 because there is no dimensions to the other side. So it is minus 1 minus a is equal to 0. So a is equal to minus 1. And b plus 1 is equal to 0. So b is equal to minus 1. So substituting it here, what will we get? Minus 1 minus 1 minus 3 of minus 1 plus c. So what happens? It becomes 3 and these two becomes minus 2. Minus 2 plus 3 plus c equal to 0. So c also becomes minus 1. So it is 1 plus c is equal to 0. So c is equal to minus 1. Oh, how? C should be minus 1 actually. Yeah, so I wrote here as correctly mu v power minus 1 rho power minus 1 h power minus 1. So it becomes mu divided by rho vh. So it is mu by rho vh or rho vh by mu. So basically it is the Reynolds number. So it is a dimensionless number actually. I change it. C is minus 1. I hope you all got that. So now we got pi 2 as well. Now we have two more groups. So pi 3, we are calculating it based on sigma. Just a minute, I'll come. So yeah, coming back, pi 3 is based on sigma. One second. So pi 3 is based on sigma. So now instead of mu or pi delta p by L, which we used in the pi 1 and pi 2, now we are going to use sigma. So sigma into VA into rho B into HC. So unit of sigma is per second. So it is T power minus 1. So V is meter per second. So it is L T minus 1 to the power of A. And rho is kg by meter cube. So M L minus 3 to the power of B. H is L. It is to the power of C. So after that, again for M we will have only B. And for L we have A minus 3B plus C. And for T we have minus A minus 1 minus A. So after this, again we will be equating it to 0. We will have A is equal to minus 1, B equal to 0 and C equal to 1. So we are going to substitute it in that. So pi 3 becomes sigma V power minus 1 rho power 0 C H power 1. So it is H into sigma divided by V. So if we look at this particular expression, what we are getting is that sigma is minus 1 by, sorry, S power minus 1 and it is H is meter. So meter per second divided by meter per second for velocity. So it is obviously a dimensionless group. So now we have found the dimensionless group for 3 and finally we have one more, pi 4. Pi 4 is based on VW, that is wall injection velocity. So what we are getting is pi 4 is equal to VW into V power A rho power B H power C. So VW is L power T minus 1 and VA it is LT minus 1 to the power of A. Rho is M L minus 3 to the power of B and H is L to the power of C. So it is what we will be having, M is B, L is 1 plus A minus 3B plus C and finally T is minus 1 minus 1A and then that's all. So after that again it becomes B is equal to 0, A is equal to minus 1, why it is similar, and B 0 means this becomes 0, A minus 1, so these two gets cancelled. So C also becomes 0. So that is the difference. So A is minus 1, B is 0, C is 0. So now we are substituting here. Pi 4 is equal to VW divided by V. That is V minus 1. I mean V minus 1 or VW divided by V. So, so basically we are asked to write the dimensionless function in the question. What was asked? Using the dimensional analysis, give the expression for this problem. We are asked to write the expression for this problem. So where f denotes the general function. So here delta p by L is equal to function of all these things that we have written. So building dimensionless, we have built 4 dimensionless groups. Pi 1, pi 2, pi 3, pi 4. So now we are just writing a final dimensionless form combining everything. So it is function is equal to pi 1, pi 2, pi 3, pi 4. So it is delta p by L, h by rho v square dot rho v h by mu dot sigma h by v into vw by v. So we can take it to the other side and then we will be having delta pi by L h by rho v square equal to function of rho v h by mu, sigma h by v, vw by v, whatever things. But the general expression is this one. So that is how we write question 5. So I hope question 5 is clear to every one of you because it is one of the basic problems which will help in solving many problems and many questions subsequently arising from the particular problem statement. So that's it for question 5. I am assuming it is clear. If you have any doubts, you can stop me and ask anytime. So, since we have only 40 minutes left, okay, we'll go to question 6 actually. If you have any doubts, we will discuss at the end. So, question 6, the fourth pi group pi 4 is given by dash. Option A, VW by V. Option B, VW cube by V cube. Option C, okay, it is square actually. Square. Right. Fourth pi group is given by VW by V and VW square by V square and VW cube by V cube or square of VW by V. So since it is a dimensionless group, whichever power we raise to, it doesn't matter. That is what we have seen, right? And basically here, here it is VW by V, but it can be VW by V the whole per square or VW by V whole cube, or it raised to the power of anything, doesn't change the dimensionless factor of the question. So the right answer is actually all of these is the right answer. So answer is, okay, we have one more option, that is F, which is none of these. But we know that the right answer is all of these. That is option E is the right answer. So all of these is the right answer. Now we are going to question 7. In question 7, we are given that a tank of length L filled with water up to a depth h is made to oscillate. Then the surface of water will also oscillate back and forth at a frequency sigma, which is assumed to depend also and only upon water density rho and the acceleration due to gravity g. Using the dimensional analysis, give the expression for this problem where f denotes a general function. So again, this is similar to the last question. We need to identify the groups. So first, what is given? We'll write all quantities. So first one was, we are given tank length, we are given tank depth, and surface will also oscillate back and forth at a frequency sigma, which is assumed to be depend upon water density and acceleration due to gravity. So we have gravity, sigma, water density, and one time characteristic length. So 4 quantities we have. So first we'll list all quantities and write their units. So first one is frequency. So it is sigma. It is represented as sigma. I mean, I'm not sure whether I'm pronouncing it is right or wrong, but anyways, I just forgot what it is called. So but its unit is per second, so it is 1 by second, and we write it as t power minus 1. Second one, it is length, characteristic length. It can be L or it can be H, so its unit is meter and it is represented as L. And third one, it is gravity and its unit is m, meter per second square. It is represented using the symbol G. So m is given by L and s square is given by minus 2. So it is L t minus 2. And finally we have density. So it is given by rho and its unit is kg by meter cube and it is m L minus 3. So these are all the quantities and the corresponding dimensions. So now after this we need to identify number of pi groups. So the number of variables here is actually 5. So so the frequency is assumed to be depend on so frequency and 5 variables. So it is number of variables is 5 and fundamental dimensions we have 3. So I'll change it here. Fundamental dimensions is actually 3. and expected dimensionless group is n minus k, so it is 5 minus 3 2. So when we choose the repeating variables, we need to make sure m, l and t are included. So we can take g, so it is l t minus 2, and second one for m we can take density, so it is ml minus 3, and finally we can take one characteristic length, so h we have taken and it is l. So the non-repeating variables are obviously sigma should be there, and another one characteristic length we have taken. So now first dimensionless pi group is based on sigma. So it is pi 1 is sigma into repeating variables. So it is g, rho and h. So g is a and rho is b, h is c. We are just assigning some a, b, c exponents to these pi 1 term, and pi 1 is sigma is per second, so it is t power minus 1. G is L t minus 2 to the power of a, and rho is kg by meter cube, so it is m L minus 3 and here to the power of b, and h is L to the power of c. So after that what we will get is we have to separate out m, l and t. So m is b, L is a minus 3b plus c, and t it is minus 1 minus 2a. So what we can get it from here is b is equal to 0 and a is equal to minus c, and a here is equal to minus 1 by 2. So if a is equal to minus 1 by 2, c becomes 1 by 2. A is minus 1 by 2, that we are getting from here. Minus 1 is equal to 2a, a is equal to minus 1 by 2, and b is equal to 0. And if we substitute b equal to 0, we will have a is equal to minus c, or c is equal to minus c. So c becomes 1 by 2. So now we are substituting the exponents in this particular form. Pi 1 is equal to sigma into g power minus 1 by 2 rho rho power 0 h power 1 by 2. So it is sigma g minus 1 by 2 h 1 by 2, or sigma h by g to the h by g to the power of 1 by 2. So instead of having h by g to the power of 1 by 2, what we are doing, we are squaring the whole term. So sigma square h by g. So it becomes this by squaring, or else sigma into h power 1 by 2 divided by g power 1 by 2. That is also right one only. That is not a wrong thing, but this is also right thing. So next we have pi 2 group, and pi 2 here we are taking one more variable, that is L. So we are taking L now. So what happens? Pi 2 is equal to L into g power a into rho power b h power c. I hope it is clear. Instead of sigma we are using L here. So it becomes L unit is L, because L is meter, L is here L, and g is meter per second square, so it is L t minus 2 to the power of a. Rho is m L minus 3 to the power of b. H is again L to the power of c. Now we are again splitting the m, L and t terms. So m is for b only, and L is 1 plus a minus 3b plus c. And for t we have minus 2a, that's all. So what we get from here, a minus 2a is equal to 0. So a is 0, b is equal to 0. And when we substitute a and b as 0, we will have 1 plus c is equal to 0 and c is equal to minus 1. So a is 0, b is 0, c is equal to minus 1. So we are substituting back in here. So it becomes pi 2 is equal to L g power 0, rho power 0 and h power minus 1. So basically it is pi 2 is equal to L by h. So L h power minus 1 or L by h. So basically this is also a dimensionless group. So L is meter, H is meter, both gets cancelled out each other. So pi, it is not pi 1, it is pi 2. So we have found pi 1 and pi 2. We obviously from the question we saw that we will be getting only two dimensionless groups, and we got that. Now we are writing the final dimensionless form combining everything. So we will be getting F is equal to sigma square h by g. Basically this also is a dimensionless group. H is meter. This is s power minus 1. So it is m s power minus 2 divided by ms power minus 2, and this is m and m. So sigma square h by g into L by h. So this is the final function which we can rewrite it in any form as a function of anything. So that is the beauty of it. So that is for question 7. Now we are going to question 8. Now for in question 8 what we got is, okay, 8, 9 is quite similar and 10th question is quite different. So yeah, so we can do that. 8th and 9th is like similar to what we saw in the previous problem only. First question 8 is similar to question 1, but question 10 is a different application. Maybe problem wise it may look similar, but it is a different application oriented problem, so it is quite interesting one. Anyways, we'll solve it 8th one first. For axial flow through a circular tube, the Reynolds number for transition to turbulence is approximately 2300 based on the diameter and average velocity. If d is equal to 10 centimeter and the fluid is kerosene at 20 degrees Celsius, which has a dynamic viscosity, again it is not a dynamic viscosity, it is basically a kinematic viscosity, of 2.78 to 10 power minus 6 meter square per second, find the volumetric flow rate in meter cube per hour that causes the transition. It's a kinematic viscosity, but anyways. So what are we given? We are having an axial flow through a circular tube and the Reynolds number is given as 2300 because the flow is transitioning to the turbulent regime, and the Reynolds number is based on the diameter of the pipe and the average velocity of the fluid, and the diameter of the pipe is given as 10 centimeter and fluid is given as kerosene whose kinematic viscosity is given as 2.78 to 10 power minus 6 meter square per second, and we are asked to find the volumetric flow rate in meter cube per hour that causes the transition. So now again a similar problem. So we have Reynolds number, we have fluid properties known, and we are just asked to find the volumetric flow rate in meter cube per hour. So now we have to find the velocity first. So we'll write the given. So Reynolds number is given as 2300 and diameter of the pipe is 10 centimeter and it is 0.1 meter, and fluid is kerosene at 20 degrees Celsius, and viscosity is nu is equal to 2.7 into 10 power minus 6 meter square per second, and we are asked to find the volumetric flow rate in meter cube per hour that causes the transition. And yeah, I mean, since the problem is already known, why can't we just I mean you people do and we'll discuss the answer. I'll give you 2 minutes time. I mean, it is similar to what we did in the first problem. So first we need to use the Reynolds number and calculate the velocity, and later using the velocity we need to calculate the volumetric flow rate in meter cube per second, and after that we need to convert it to the volumetric flow rate in meter cube per hour. So yeah, I mean if you can solve it, it would be very good. So I'll wait for 2 minutes, and if you can give the answer, it is very good, or else we'll discuss the answer here itself. That is also not an issue. Yeah, it is 49. We can wait till 51. 3, 3.5 minutes. Okay, we'll see. 3.5. Oh. Are you sure it is 3.5? I'll check my calculation again. One second. It's 2300 into 2.7. What is your value for velocity? Which, I mean, what value are you getting actually? Okay, 1.75. Yeah, thank you. So it is 1.75 only. So yeah, the answer we are getting. So which is the right answer? So just to quick recap how we did it. Reynolds number is rho v d by mu. It is nu d by v d by nu, and it is v is equal to r e nu by d. And after substituting everything in the formula, we are getting v as 0.0621 meter per second, and we are substituting in the volumetric flow rate formula. Q is equal to v into a, v into pi by 4 d square. So we are getting the flow rate as 4.87 into 10 power minus 4 meter cube per second, and converting it into meter cube per hour, we are getting it as 1.75 meter cube per hour. So yeah, thank you. I think it is Kavipriya, right? Kavirayani. Shri Bharati Kavirayani. Thank you. Your answer is right. So now we will go for question 9. In question 9, what is given is that determine the dimension of the following combination of variables. Each symbol has the usual meaning. Option, I mean, we have to find it for all, it is not options. So first one, it is rho into u into dou u by dou x. Second one, it is integral of p minus p naught into dA from 1 to 2. And third one, it is rho into cp into dou square t by dou x dou y. And final one, it is triple integral of rho into dou u by dou t into dx, dy and dz. So we need to determine the dimension of the following combination of variables, and after that we need to match it with the given question actually. So if denotes the dimensions of the enclosed quantity, which among the following is right? So it is, I mean, this square bracket denotes the dimension of the enclosed quantity, either A, B, C or D in that sense. So which among the following is right? So first one, it is A not equal to C and B equal to D. Second one, A equal to C, B not equal to D. And for third one, it is A not equal to B not equal to C not equal to D. And option D, it is A equal to B equal to C and not equal to D. Option E, it is A not equal to B equal to C equal to D. And F, it is A not equal to B, C equal to D. Option G, it is A equal to B, C not equal to D. H is A equal to B equal to C equal to D. And answer is option A, that is A not equal to C, B equal to D. So yeah, we'll see how that is. Question 9 solution. First one, let us take rho u dou u by dou x. So its unit is, rho is kg per meter cube, u is meter per second, dou u is meter per second, divided by x is meter. I think I should have put some dot, right? Otherwise otherwise it might be confusing. So it is meter per second by meter. So it is kg by meter cube into meter per second into meter per second by meter. So what happens? Kg remains And in the numerator we have 1 meter, and this meter gets cancelled. So we have 1 meter divided by meter cube. So it becomes meter square in the denominator, and s we have s and one more s here. So it becomes s square in the denominator. So second one we have integral of p minus p naught into dA. So we have P is Newton by meter square or kg meter per second square by meter square into A is meter square. So we have kg meter per second square divided by meter square into meter square. So what happens? This meter square and this meter square gets cancelled, and we will be left with kg meter per second square. An option for the C problem we have rho into Cp into dou square T by dou x dou y. So we have kg by meter cube for rho, and it is Cp is joule per kg Kelvin. So joule is Newton meter. So Newton meter by kg Kelvin. So this whole term denotes that. And here it is dou square T. So it is Kelvin divided by dou x dou y. So it is meter square. So that is how it is. And we have kg by meter cube into Newton is kg meter per second square into meter by kg Kelvin. What happened to that Kelvin? Okay, this Kelvin and this Kelvin got cancelled out. So it is left with 1 by meter square. So after that we have this kg and this kg also gets cancelled out. So we will have 1 kg, and for meter what we will be having? Meter and this here. So meter square divided by meter, and we have one more meter square. So it becomes meter square gets cancelled, and we will be left with meter cube. So here if we count, it is minus 3 plus 1 minus 2 plus 1 minus 1, and it is minus 2. So it is minus 3. So 3 goes to the denominator. For seconds we have second square. So it remains in the denominator itself. So it is kg by meter cube second square. And finally for D what we got? Rho into dou u by dou t into dx dy dz. So rho is kg by meter cube, u is meter per second divided by second into meter into meter into meter. So this meter cube, we will have 1 kg, and for meter cube we can cancel this meter cube and this meter cubes. So we will be left with 1 meter from here, and for seconds we will have 2 seconds, so in the denominator. So it is second square. So if we compare, we are having kg in the numerator and second square in the denominator, common for all. But for B and D we have 1 meter in the numerator, whereas for A and C we have meter square in the denominator and meter cube in the denominator. So A and C are different, but B and D are having same units. So that is the why we went with, this is just to denote units. In the question it was given like that, right? That's why I am writing. So we have B and D having same units. So it is highlighted. Kg meter per second square. So B and D are same, and A is not equal to C. A and C are not equal. So that is how we got the answer for question 9. So last question, why it is going? Okay, last question is a simple problem actually. It is similar to question 7, I guess. We'll finish it off with question 7. Question 10. Even though it is 5, just a few minutes, it will take 5-7 minutes only. So in the question 10, what is given? A sphere of diameter d moves at a steady velocity v through a fluid with density rho and viscosity mu. The drag force acting on the sphere is known to depend on these quantities. So it is these quantities in the sense diameter of particle, steady velocity v, and density rho and viscosity mu. Use dimensional analysis to express the drag force F in terms of a dimensionless function involving Reynolds number. Identify the number of dimensionless groups and interpret them physically. So that is the question. So first, for solution, first drag force on, we'll write what is given, right? Drag force of F on a sphere depends on fluid velocity, fluid density, and spherical diameter d, and fluid viscosity. I mean, this is not fluid velocity actually. This is particle velocity. Particle is only moving, right? So particle velocity, fluid density, sphere diameter. Okay, these are all the given. So now after that, as we do in previous, as we have done in previous problems also, we are writing the all the quantities. Oh, it is not fluid velocity. Particle velocity. So it is, and particle is only moving through a fluid. Fluid will be almost stationary in most of the problems. So velocity is v meter per second and its dimension is therefore L t minus 1. Next is sphere diameter. Its dimension is, I mean, it's represented as d and its unit is meter and it is L. Finally, it is fluid viscosity and it is mu kg by meter second. So it is m L minus 1 t minus 1, and fluid density it is kg by meter cube, so m L minus 3, and drag force, since it is force, it is Newton or kg meter per second square, so m L t minus 2. So that is how we arrive at the solution. So listing all quantities, we got this. Now what have we got to do? We have to identify the number of pi groups. Using the Buckingham pi theorem, the number of variables here is 5. Number of variables is 5. I mean, number of variables are 5. So number of fundamental dimensions is, if we look at it, we are having m, L and t only. So number of fundamental dimensions is 3. So it is m, L and t. Expected dimensionless group is k n minus k. So it is 2. 5 minus 3 equal to 2. So the repeating variables, if we choose, it is one is v, L, it includes L, t minus 1, and next one is rho. So it is having m, so m L minus 3, and one more thing is we can take d, that is L. So non-repeating variables, one is obviously f and the other is mu. So since we took density, we are taking we haven't taken viscosity. So that is the case basically. So building dimensionless groups, first one is based on f. So it is pi 1 is equal to f into v to the power of a, rho to the power of b, and d to the power of c. So pi 1 is equal to f is m L t minus 2, L t minus 1 to the power of a, rho it is m L minus 3 to the power of b, d is L to the power of c. So m is 1 plus b. L, if we take, it is 1 plus a minus 3b plus c. And for t it is minus 2 minus a. So these are all the exponents we have. So now we have to equate it to 0 as we do all the time. So if we equate it to 0, what will we get? We will get a is equal to minus 2. So minus 2 minus a is equal to 0. So a is equal to minus 2. and b is equal to minus 1. So 1 plus b is equal to 0. So b is minus 1, and we are substituting both of them in this particular term. So it becomes 1 plus a. So it is 1 minus 2 minus 3b. So it becomes plus 3 plus c. It is minus 2. Sorry. This is plus c. C is unknown, right? Equal to 0. So it is 4 minus 2. 4 minus 2 is 2. 2 plus c is equal to 0. So c is equal to minus 2. So that is how we get the equation. So after that we are substituting here. So f va rho b dc. So f v to the power of minus 2, rho to the power of minus 1, d to the power of minus 2. So what happens? F by v square rho d square. So what are we reminding from this? It is f by, this is not equal, I'm sorry. So note. So it is like f, if we take some half, and instead of d square if we have a, it is f by half rho v square into a. What does that gives us? It gives us the drag coefficient. So basically it is giving us the drag coefficient, which is basically does not have any unit. So if we calculate, if we write unit also, we can see that it gets cancelled. Sorry. So it is basically F is Newton, or it is kg meter per second square, and V square is meter square by second square, meter per second the whole square. So it is meter square second square, and it is rho is kg by meter cube, and it is meter square. So kg gets cancelled, and s square also gets cancelled. So it is meter, and 1 meter gets cancelled. So meter, and it becomes 2, and this gets cancelled. So basically it is a dimensionless number. So f by v square rho d square. So it is almost equal to CD is equal to f by rho v square half rho v square into a. So a is pi by 4 d square, right? So it dimensionally the equation is similar to that. So it is pi 1 is similar to CD. Now we are finding pi 2 based on mu. So from mu what we can write? Pi 2 is equal to mu into VA rho b d. So rho b d power c. So again mu is kg by meter second. So m l minus 1 t minus 1. Again for v rho and d we are substituting everything. So what will we get for m? We will get 1 plus b, and L it is minus 1 plus A minus 3B plus C. So T is minus 1 minus A. That's it. So here A is equal to minus 1 and B is equal to minus 1. So substituting in this we will get minus 1 plus 3. So it is 3 minus 2, it is plus 1. So C is also minus 1. So A is minus 1, B is minus 1, C is also minus 1. So pi 2 becomes mu divided by V rho D. So it is mu by rho VD. It is equal to RE. So pi 2 is RE. So final dimensionless form combining everything, CD is equal to function of RE. I'll show you how actually. We wrote it directly, but basically what happens is that pi 1 is equal to this one, So it is function of this thing. And all right, this not capacity is F. Okay, let it be this one. uh, it is v square rho d square. So basically what happens is that, so it is F into, it is CD RE. So rewriting it, we will get CD as a function of RE. So that is how we get. And we know that CD is equal to function of RE, or CD is equal to 24 by RE in the Reynolds number, sorry, in the at low Reynolds number region. And yeah, that's it, that we know, right? At higher Reynolds number, for spherical particles, CD is a constant, but it is dependent, CD is dependent on RE. So that thing we all know. So where is question 10? So identify the number of dimensionless groups and interpret them physically. So we got the function as F is equal to CDRE, or CD is equal to function of RE. So that is how we arrive at the solution. So yeah, I think we covered all things for today's class. Thank you. If you have any doubts, you can ask, or else we can close the session. I think it kind of exceeded by 12 minutes. But yeah, anyways, yeah, if there are no doubts, I'll close the session. Thank you for attending today's session. We'll meet again next week at the same time, 3 p.m. to 5 p.m. On Saturday. Thank you.